Okay. I should really learn how to use the. Okay, so I can get a question. So I really should learn how to use these tools for making the for having better control over my streams, but well, not this time. Okay, so how's it going with C3? Is there any Internet of GCC as a potential backend? Is thinking about possible platforms, also soft float support. Okay. Um, okay, so, and I used it right. So, I'm watching just that I watch using MPV, so I can pause and resume. Also have some audio and noise. Yeah. Okay. So, okay. um, yes, GCC could. Okay, so let me just put these questions on here as we go along, and I'll try to answer them. So, what about um, what is it? So we have the question. Uh, what about GCC support? Okay. All right. So we're already done with that. Let's put that down there and go. Okay. So 0.7. 0.7 I scheduled way back in, I think, in 2024, around summer or so. I set down a time schedule for a release schedule really for C3, and it's been roughly one release a month, which has been like fairly. It's I mean, most people that might be following C3 would probably just don't download the latest, but it serves an important function as kind of not putting too much in a single release, and also kind of it's easier to write about and post things about the releases. So 0.6.8 is the current in progress version, and it's scheduled for mid March, which leaves a scant half a month to get 0.7 ready. So, which means actually that 0.6.8 is very close to 0.7 in feature, which is kind of not what I want, because we're doing changes. So we should have more time for 0.7. That said, it's half a month is not that bad. It's okay. But I wanted to discuss what's going into C3 or 0.7, and I also had some questions, from Alex in the on the Discord. I'll grab them and put them in here as well. Let's see here where I have those. Probably in the language. Okay, maybe it's in compiler development. Oh, and I also got a question about the flag. How long do you intend to have the flag? And that's the flag for. Oh, let me put that one as a question as well. So we're gonna have a question. So how long to intend to have this flag? And that's the just enable new generics, and also this state lib thing. And let's see here. There was something else as well. Just let me grab that question from very recently. Okay, so here are the questions. I'll put them in as well. So, oh, so I'll use the I'll talk about these out of order, perhaps. Okay. Q5. This is an insane way of doing this. Okay, anyway. What is support? So, it's just funny. And I should add in this. So we have 7 questions here. Let's see if someone else came up with another question. No. Okay, good, good. So, what about GCC support? So, GCC support, I just, this is not about 0.7, but GCC, you are definitely, it's definitely possible to basically, I think it's called GCC Git, right? Use that one. And I know that dlang is integrated into GCC, so it would be really nice to have have GCC as a backend, definitely. But it's not the main priority right now, because the main priority right now has to be to basically define 1.0 with all the standard libraries and have that kind of ready, getting everything in place. If someone would like to work on GCC, that would be awesome, but I can split my focus that way. That said, it would be awesome to have it. There's also this question about generics, this enable generics flag in the standard library. So with 0.6.8, when that development started, I started to experiment with this new syntax here. So let's go back to that and the motivation for this syntax. So we have this one right now, right? We have this syntax, and while it's working, it has the problem of, it doesn't look very much like C-like syntax, and I would like C3 to feel like there's a very small step between C3 and C. Yes, there can be more features, but syntax wise, I want to minimize what I'm adding. So this syntax introduces two new tokens into like C3. Now there's this token, which is this new and less than, this kind of symbol. Oh, I'm sorry. I'm sorry. It's kind of, it's not super late, but it's I'm kind of tired. So there's this piece that isn't this kind of token here, that's not in C, and this kind of accumulates. So the more you have, the less it will feel like C. Yes, we know. I know I have FN, but that's already kind of a problem in some sense. It has some advantages, but it's a problem too. Okay, so I wanted to have something that looks and feels more like C, not like C++, and not like Java, not like whatever thing post C++, because C++ is using the worst possible syntax for generics, which is that. Like, it's the worst possible syntax because there are so many ambiguities. Like, this is, oh, what? Could be like this part and whatever. What do you want? Does this mean? And that's not the worst part. It's just like you can get like this. You get these, left shift, and right shift things. So it's not good. So it's just in the tokenizer, both in the tokenizer and kind of when parsing and semantic and doing semantic analysis. It's just bad. And this one is super good in the sense that it's going to be it's like super obvious what's happening, but it's kind of heavy. So I've decided to go for this syntax now. Had it for test. I am not sure how to write this because this kind of looks nice if you are doing a declaration, but it's not so nice if you use it inline. But it will be in 0.7 basically. It's good enough. Maybe I'll change my mind. It's completely possible that there are problems. There is just the one problem that we have right now why it's not in 0.6.8 by default is because you can't express this because this is another has another meaning in 0.6.8. So there is this meaning of you can do a construct. You can do like a equals foo. Foo 1.2, like something like that. Or yes, we can do an array because that's like the super simple thing. So that's the way it works in 0.6.8. But if you turn on enable new generics, you have to use this syntax, which is the old, C syntax for things. When you do this, it's not ambiguous anymore, and you can suddenly use the generics, which are like this style, and there's no problem. So that's why there's a break here with 0.7. And I think that like the value of this is not that great in C3. And that's why it's going away. It's not that it's not good. I like this syntax. I think a lot of people like this syntax too. It's just that this feature is kind of not that useful because there is so much inference. So I'm hard pressed to find a reason why you should use that. If it's this situation, you always do like this. If it's this situation, you still, do like that because unlike C, you are allowed to do this. So you don't need to do the cost here. This isn't unnecessary. So you would prefer this. Even if you pass this into some function, you get the inference. So there is very few times where you actually do the compound literal anymore in C3. So that is why. That's why I feel I can jettison that kind of that behavior and do go C style on everything. Okay, I mean no. Okay, so now I have some questions. So let's see here. In C, you would be able to do it like with macros. Okay, so there's a question. Wouldn't it work doing this? Right? No. The reason is that this is also used for functions and constants. So for a function like my function, you get something like you would get something like this, and it can be ambiguated in semantics, but you don't know that this is a generic type. And you also have this problem with like this in case there's this generic type. So it's not that great, but the worst thing about it is not that. So that's not the main problem. So the main problem is if you define a function that's returning this. So let's return a list of something. So you have basically this, right? Maybe something like this. It takes an int, maybe. So let's say we have a function like this, and it doesn't, for some reason, it doesn't do anything with its argument. But okay, if I'm now writing a lambda for that type, for that kind of this kind of thing, a lambda with that would look like, it would look. Okay, we can make the callback. So we have this some function, and it is list int, and then you would have to write it takes an int, like this. So this is what it would look like. And now this is kind of, it's not quite ambiguous in this case, but it's hard to parse. So when you want to write the lambda for that, so you have some function x, and it's going to be like a lambda list int a or something. Now this is not nice because it should be like, it is not very readable basically. It will be if you can do like that. There's like also, like weird things. So once you go there, there are some really nasty things because of this. So when you start parsing this, basically you start parsing this, now you don't have any idea where, if this is a generic or this is a function. So of course we could change the lambda, the way the lambdas are defined. We could have like like something like this. I don't know. Anything could work, but you see there's a problem when this thing happens, because the parsing here and that parsing has to be very, very different. So and the problem with, like, in this situation where you want to parse this, is that the parser needs to have a syntax that will include both this kind of thing, which is just constants and types, and this, which would be like, oh, it's default arguments and all sorts of things. So it's not very nice. Just not nothing you want. Is it possible to store types in a struct? You can store types in a struct, but in the sense that you can do, you have type ID. So the type ID type is basically an identifier for the type, and at runtime, you can get all the information about that particular type. But you don't really, statically typed language, you don't pass around, the type itself, because there's not much use for that. Because you can't really put the type in, you can put types inside things at compile time, but not at runtime. So macros can certainly take types. And you could store the type ID, and if it's a constant type ID, then you can turn that into a type. So you can put that in a type location. So you can certainly have a type in that sense in a struct. But at compile time, it would only be, getting actually the type out that at compile time would be, it would not be useful at compile time. But you could get some information at the runtime, of course, by putting the type ID in a struct. Okay, right. So let's go continue. So so do you think the question for this one? So let me the question for this one is, yes, it will likely stick. I don't have any other alternatives. We tried this one as well, and it also has issues. Of course, the main issue is when you have something like this. Is that a generic with a 3 as the parameter, or is it a normal array? You don't know, and that means that parser need to speculatively assume it could be either. So it's not that nice. So you prefer to not have that. Even though this is actually easier than the parenthesis case, because the parenthesis case is you have to be even more accept even more. In this case, you just accept that it could be a type that you index into, and then you can just switch. You can look at the first thing. Oh, does that look like a constant or something? Then you have to continue. Or if it's a constant and if it's a comma after, then you would know, like, the places you would know if it's like a list and you see three comma, then it would know. If it sees like int, it would know. It's a generic. If it sees a three, it just see the three, it doesn't know. If it sees foo, it doesn't know. So you have to have like the comma or the type. And you can say like, okay, so we would just have the type first. And I actually, what I did was I looked into whether we could just skip the constants, and we can. For the standard library, you can do that. It's not a problem, and can actually hack it by saying that, well, the constant, you can, any positive constant can be, you can replace that with a type, because you can say like, okay, here's an int int array of a specific types, like an int array of int with the size of 2000. That could be like an argument 2000 for the generics to handle, but that's very very hackish. But that was, some people did that before we actually had those constants in the generics. That said, yeah, I think this is the best idea for now. For now, I I will not like it. I will not add this kind of syntax. That's worse. Better. There's a better chance of having this or this to work than to have this to work. Okay, so have you finished converting all generics in the API in lib7? So lib7 is the thing, the alternative. So we have clearly in lib7, that's the alternative for, that's basically what is going to happen in 0.7. So 0.7 will have lib7. So then lib will go away and will be replaced by lib7. So have I finished converting all generics in API in lib7? Yes, I think everything is converted, should be converted there. There shouldn't be any. Like you saw, there was none of that old syntax. And I've done the changes that I wanted to do to init and so on. So I should talk about init too. So let's talk about that one. Init. Okay, have you finished convert? Okay, so that would be a yes, basically. Okay, so I think, or maybe it should be anyway. So would you suggest migrating to lib7, or is it under development until April? I would say start using lib7 now, because it's just right now I am going through all the functions, and the new things are not really going to change. So it's just the old things that are changing, and that's something you will have to do. I'm not doing things like, oh, this looks good, but then I revert it immediately. Or there's a minimum of those anyway. There are very few. I did the whole, trying to change how path worked, and I worked on that on my computer, and I did huge changes, and then I rolled back almost everything before I checked it in, because that was just an experiment. So I'll do experiments I do locally. So I would suggest moving to lib7. So okay, what now we have this one. So what are other plans are for breaking API changes API changes for lib7? So The main changes that I've done is basically the init. We get to those. I'm not. There's one more thing I would like to do, and that's something. That's issue number. What's that? Let's see here. It's issue. Okay, there's a bug in here. Okay, what's it called? Um, mm, Add common fault error into standard library is something that Alex suggested. And that's number 1984. 1984, yeah. There are a lot of these like search result missing and so on, and that's fine. I think that worked perfectly fine, but it's kind of hard to remember. And we don't need to have all these. You can have like if you have a good name for this collection of errors, they can actually go into the same thing. I think that maybe the IO errors should go in like their own thing, not to have them like the IO stuff in it for itself. But there are a lot of other errors that you can kind of think of. So basically, I would like to have that one in lib7, and if I do, then obviously this error return will change, and you would have to, you know, if you are looking at explicitly those errors, those faults, then you would have to change. So I am hoping to kind of do that before 0.7. So we have a list of faults that you have, like these common faults that are in built in, and then you may maybe like mostly use them, and then sometimes you go for your more custom ones. So that's my plan on breaking things. But otherwise, let me have a look. So the other things are mostly, I think, fine. For now, there might be other things, threads maybe. Um, some of those things like the 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 fixed pool and the pool, both of those are kind of bad and shouldn't be used. So that's something that would need to change. I think I'll have a look at that. I recommend writing your own thread pool. Other than that, I don't know. I think those some otherwise things are mostly okay. There are some, of course, there are deprecated things. So those deprecated things are going away. The map is gone, but maybe hashmap will be renamed map. I don't know. And there's one thing that I want that is missing here. So you have object which you can put things in, but I want an any map. So there's going to be like there's an any list, but there's going to be an any map. So an any map will, you can put anything in it and will manage that particular the memory, the underlying object, so you can do that safely and don't have to. Well, it's going to be work like the any list. I hope I can do that for libs7. So, but that's not breaking; it's just adding two things. Okay, so how? So now I just before I answer question two, let me do. So I plan to support and bug fix all libsec6. Um, I always plan to support the older ones to kind of if people need a bug fix for um 0.6 and they because they can't use 0.7, then I'll definitely do that. Otherwise, it's kind of otherwise I won't, because there's no reason to kind of update that unless people run into this bug and they actually need it fixed. It's just a waste of development time. But if people are using 0.6, I'll definitely bug add bug fixes, backport those. But we're not like LVM here, that where we have these like have to backport things. Um, so yeah, I hope hopefully people will get used, like go to 0.7 and be just happy about that. But and if they're not, they can stay on the 0.6 one until they are ready to migrate. And it's it's fine to just stay on 0.6 for a long time. That's the point. Like you have your code and you're working with your code and you don't want to fix anything, yes, go with 0.6. And then just let me know if there are bugs that you need fixed. Okay, and so hopefully 0.6.8 will have some nice fixes. Just and I think and that ties into question two. So the question two: how long do I intend to have this flag so enable new generics? So my plan is now. I've been thinking about this quite a bit, and I think that maybe it's time to do a fairly early branch of 0.6.8. So it might be that 0.6.8 is already released, um, next week or something, or even this weekend. And then after that, it's just 0.7 and just have a month of 0.7. So when 0.7 goes into the main line, the lib7 will replace lib. So I might actually start doing this very early, even like I might launch it tomorrow or something like that. And so dev will then hold 0.7 and master will hold 0.6.8, and they will be developed in parallel. And so with that, the downside of that is that because the only thing that will create latest is the master. So you would have to compile for it yourself if you wanted 0.7. But yeah, so let me see if there are any other questions. Okay, so some questions here, right? Okay. Okay. Doing a list dollar int or maybe, yeah. Okay, so there was a question. Uh, yeah, it was funny. Someone said you can do, you could do like this, and then have that, and then the dollar would show it's expensive. It's just to create that. Oh, seriously, we're talking about this, but because ambiguity, this is essentially, it's not clear here that this is creating a, like if you had something like this would be a generic no, sorry, a compile time variable. So this thing would have to have very special, you couldn't do this. You would have to do like this or this, and that it kind of could work, but this will always work. So this is all our alternative, and this has been discussed a bit. And this has the advantage of not having ambiguities. The other one that was also discussed is this one. So that one is also under discussion. But if this one doesn't pan out, then we'll look at this. This is like the second thing. The downside here is that this is also kind of, it's not as nice to read, and it looks a bit alien. Okay, and okay, so but yeah, we think so. No, it won't be like it couldn't be like something like this. And bool, that would be really weird. So like, oh yeah, no. It's that would have to be a parenthesis in order to disambiguate that one. So like that. I already, I mean, you see the IntelliJ parser will parse this. It'll highlight this because I already prepared for that as a test. Okay. Wiesengrad, I have to say you have a cool sounding voice. Oh, I think my voice is horrible. But anyway. Okay, send another thing I like about C3 is how small the compiler was. So the last time I checked, the whole compiler was only around 1K clock. Less code means less bugs and less code to maintain. It's actually yeah, it's around 70,000, I think, right now. Probably more now if we start looking at things because of the, you should. I mean, yeah, yes, the C code it's the same, around the same. Odin has actually the same similar line count. So it's just like other some other compilers have a lot more. I don't remember Rust, but it was like 700,000 lines of code, and Zeg is like 500,000. So it doesn't need to be that long. Okay, so the also the since the compiler is written in C, that means it should be really easy to bootstrap, especially if we get a C backend, so we don't need LLVM. Then the whole toolchain is more or less bootstrapable only with a C compiler. Yes, it should. I mean, the C compiler itself, a C compiler, you can get that for pretty much everything. Um, and so the nice thing about having a C backend later on is to be able to just compile it for anything, on anything. And yeah, it would be easy to bootstrap the compiler, but I don't want to do that before 1.0. Um, and also because like do this self-hosting thing is it's not very useful, and I think leads you into bad conclusions about how what kind of functions you need and how memory management should be and so on. Okay. Uh, yeah, so the C backend, the reason about the C backend, because that's like the request in here, sounds great. So how far away is the C backend? So the C backend is, I wanted, when I started working on that, I immediately felt that, okay, something that I also noticed when I was working on with the tilde backend a little, is that there are a lot of functions in the lowering. So we are lowering. So let's if we go to LVM cogen, so you can see there are several files here. Some of them are smaller, but especially this one for expressions. This one is huge. So it's like oh, I think it's huge, but it's like 7,000 lines of code, right? And so you have to implement everything like this in C as well. So it's a win if you kind of can reduce how long each of these things are and kind of make it smaller. And what I did when I got to that point, I was like, okay, let's go back and do change things so that it's more of an easier IR to lower. So I've done some work on that, and that's why actually there are some things like unresolved expressions and so on. They're not. It's a bit different. So I'm working on that, but I don't want to start the C backend until the work on that the part where I kind of linearize um, the uh, um, the AST. Until that is done, I just want to I just want to postpone the C code so as to not do things twice. Um, so that's it. Okay. Mm-mm. Okay, for sake, I guess it's worth I have to see how Tilde is doing. Last time, still some things that didn't work. And the reason why, by the way, my Tilde was in C3. Some work was starting way back. But the problem is that I'm on Mac and Tilde was started on Windows. Mostly worked on Windows. So that meant that I couldn't even compile a simple, hello world with tilde. It wouldn't link, and uh, that made it impossible for me to actually do any work on the back end for the tilde backend because basically I couldn't get it to work because it wasn't really finished. So now it's picked up for Odin, but I feel like it's like this. It's moving slowly. So anyway, it's I want to have like I want to eventually I want C3 compiler to have better analysis. In order to do that, I need to have a better IR for analysis. And better IR for analysis means removing a lot of tree-like. Uh, the right now it's like it's a very C-like form, which is I guess good for turning into C in that sense, but it's you want it kind of like an SSA form where you have single where you have like everything is kind of assigned to temporaries and then you can do range checking and so like and things like see where things are used and so on in a nicer way than you have on the tree. Because I did it on the tree, but it's you have to add so many nodes that carry information. So I don't really like that. I don't really like how loose and uncompact it is. So I would like a very compact resulting, like the thing before I go to LVM. So basically, like the mirror, I guess, like the LVMs, but my own. And to do that, I'm kind of doing it. I'm trying to do that analysis and then turn that into a more flat IR that I might do more analysis on, and then maybe move that back so that the things going into um, the AST already is prepared to be more flat. But that's later work. Okay, so was there anything else? Yeah, yeah. I mean, the SIG has a lot of different things in it. And then it has, I mean, the whole standard library and sort of kind of actually is part of the compiler as well. So yeah, it's complicated, but I guess like all of the self-hosted things kind of gets very long after a while. I mean, it's no problem that things are in C because C is very. It's not like it's not a problem. I mean, you feel like you should be dog fooding, and in the one sense, the lack of dog fooding is bad, right? You want to use. I would like to use C3 when compile when writing this, not because I think C is so bad, but because that would help me improve and catch bugs and so on. But on the other hand, there are other reasons why you shouldn't do that because I want um, to have something that's I know this is not it's not complicated to compile it. It's people can use it as references as when you write the compiler. That's really cool. Like if they are doing something else, like they are actually doing some C like, and they can have a look at my code and actually learn something. I would like people to be better at C as well, not just the like say, oh, let's use C3. I think C is a pretty good language to use, except for it being very hard due to the standard library. But it's not bad. I mean, sometimes I wish people were using Pascal to learn how to program, because that was an awesome language for just getting clarity. And it has some built-ins that made it much easier to work with than C. Because for C you don't get anything, but if you do something like Turbo Pascal, I use that one a lot. You get so much for free, so yeah, it's very nice. Okay, let's. I digress. Um, so this flag here, basically, we are trying to get rid of that, and once I do 0.6.8, I probably will remove, the lib7 from here, maybe. I don't know. Anyway, going like further, I'm just going to list a bit of the changes. What's deprecated and getting removed is mostly recently, we're talking about construct. So I know some people were using construct, but I mean, no one is defending that. The problem with having this kind of construct, which allows you to kind of do string ABC, like a string X is like string ABC, this kind of constructor, static constructor, is that I mean, usually this is not allowed in C3 to avoid the problem where people don't know where they're putting. So you put the things as a static function, like a normal free function. Sorry, free function, um, or if you should put that in like this, right? And you don't want the people to be confused about that. But there are some uses, like if you actually want to have something very, very, very much create something on this on. I'll show you. So there is this common pattern where you have a list. Oh, this one I can show something else. So then do a init, and right now the new pattern for things going into C is having this. We'll talk about that as well. So init, and then you start pushing things to that. But the idea was to have like this, and then you would have create, something like that, and then you would push. Like basically, you save one line here, this necessary init. Yes, you can write this. It's actually shorter, but people are very much used to this, and yeah, so sometimes that could be nicer. But this makes it gives just these two ways of doing it. And was for trial, and it's been in like 0.6, and it will be in 0.6.8, but it will be deprecated, right? Because we will not have it in 0.7. So that one is gone. So what was going away as well? This syntax, this is the old syntax, so it will be removed completely. Then another thing that actually this is something language has had for a very long time. One of the features of language, right? So it's this: you can turn anything into an expression. In GCC, you have something like this. It's not quite as powerful, actually. It's and because you can do a lot of external expressions, but you can't have this jump out of things. And a lot of it's very popular to kind of have this behavior, but to have like something expression based, right? So they would have, it would look more like, while true. Maybe you could think that a while true could return a value and will look like this. And actually, that's been suggested as a kind of, it looks more like break, right? So this is a common way to do this. But the thing is that this is not used very often. It's used sometimes, but it's mostly useful if you have a language where you have const for normal variables, which you don't have in C3. But if you have this kind of thing, then doing this init is very important, because otherwise, if you want to have something and it takes several things to kind of create, you have to create a new function, or you have to do like y is equal to something y, and then you do these settings, these if sets, and then finally you do like the const int x is equal to this mutable y, and that's like a pain. This is very painful. So that's why you want this. But since we don't even have the const thing, there's no reason to have it. Other than it kind of looks cool and it's like, oh, so there's this selling point. So it's going away. It pains me, but it's going away. Okay. So those are gone. And there's more. The other thing, like this actually huge thing that when you start using, is that using 0.7 will be this. May wait, I'll just go for some other questions. So with flat, do you mean less necessary? Flat. I don't know what the question about flat is. Okay. Anyway, so you will see a lot of code looking like this in the 0.6. So if you have 0.6, it will look like temp init, and then you push something and use that. Because you want to use the temp allocator, so you do this. And then sometimes you will see this, and then it's using the heap allocator, because you're allowed this kind of serial initialized to use the heap allocator. So this is fine, but then you must free it if you push it. But if you don't do that, if you don't have this, you don't need to free it, which is it's been a weird thing, but I wanted to keep that serial initialization, that you didn't need to do this. And remember, this was the way it looked. So this is the way it used to look. New init, and this new part was because it used the heap allocator by default. Otherwise, you would have like have to use allocator heap, right? So this was the thing. Now we kind of go away from we're making changes. First change. There is no new init. This one is going away. There is no such thing in lib7. Instead, you just use init and you use the memory. But while this one is still there, right? It's still possible to use this. There's a shorter one. It's just mem. So you do, rather than doing this, you will do that. So they are, that goes to this one, right? And the other change is that if you don't do anything, you don't have anything, then you use, the list will use the temp allocator. instead. So this is perfectly fine non-leaking code because it's the temp allocator. And the same goes for the other things that had zero initialization that you didn't need to do. So the D string, also temp D string. The lists, the hash maps also. So you're gonna, like, by default, you will always get this temp allocated thing. And of course, you would need to use pool around that to kind of kill those, but that's less of a problem, right? This is more correct. So everything, like the temp allocator is going to be very, very even more used, but you can use it implicitly now. And that seems like, okay, why this doesn't isn't that a bad idea? And originally, I was thinking of having the temp allocator, but I felt that it was the wrong. It was an unexpected default. People might assume that they could, return the list even though they didn't, initialize it. In fact, I was mostly probably thinking of that I would have to go away. This list implicitly in it would need to go away. So I mean, the original thought was maybe I would need to do like this, is list, basically a list new, right? This kind of thing. But now that's going away, right? We are saying that these are this one now is temp allocated thing. Unless you do, like, you want to init that one to something, and then you do mem, right? So let me pull up some examples, perhaps, of that. We could go to the unit test. So finding files, can we do some init mem, maybe? Is it not? So okay, we're getting the old ones. So the old ones would look like this, right? So if you have something like that, what you can do when we want to do this, just delete this, right? That's what happens, everyone. So let's look at this one. So we have a bunch of inits, right? So we have init. So no, it's a 7. Finding files. So, oh, we still have some. Okay, this will be fixed. This still has temp init. So the temp init also will rename t init. So if you see something, it's going to be t init. So talking about changes, so everything that has temp init and stuff, is going to go away, and it's going to be like the new one, which doesn't have that. So more stuff on the temp allocator, going more all in on the temp allocator. That will happen. And for memory, you go for that. Right now, to do the temp allocator, you do tmem, right? But that's a call. Maybe that goes away, maybe not. There are some ideas around that and reasons why it looks like that. What else? I want to note that there are some things that are kind of not working well right now, I think. So the ASM, the inline ASM still has, like, I need to go through that. I did started to doing some things on the stream, but I really will I want to really look at that and try to remember again how it worked, and then fix everything for at least x86. So we have like a perfectly working x86, and it has to add labels so that you can do jumps. So once that's done, it's going to be fine. We need to do like clobbers, so you can just say, okay, let's clobber things. That's not in either. But Yes. So what we're missing, so the ASM is going to needs fixes. Like some things work and they work, but the things that don't work, they're not fixed. Um, there are probably other things. Let's see here. Looking at through the issues now. Okay. So of course the backends, right? And then there's also the problem of creating headers. So the headers should be created again. That's something that I haven't really um, uh, well, every time I look at that, it's like I'm not sure how to handle it because we can do it in basically two ways, depending on if you want to base that off as C3I file or the source code. There are different advantages, and I have to make a decision. But to make a decision, I really have to use it, and I have to have a use case where I really do these exports. So once you're there, you kind of can get a feeling for what's better. But before that, doing it out of the blue, it's not really. It's just going to be wrong, regardless of whether what I pick. Um, so we also need like clarify conversions. There's been some changes to fixes to that, but there's sometimes it's a bit nicer than it should be, and also clarify. But most of all, clarify what the fine will check and what it will not will like test for. That's not very well defined. And that this is kind of going into 0.7 and have to be fixed in the various 0.7 versions. But we are going into a 0.7 with kind of, I'm pretty sure that this is the right way to go. We have tried the new int. We tried different things, and I was trying, having one test was to have like, oh, you have init, which takes this allocator, and then you have like for everything you would have like new init. That would be like the heap out. That would be like this, and then the heap, and then finally the temp init, which would be the temp allocator. The problem with having these prefixes is that sometimes they don't make sense. It's like they mean something else, and then it's really hard to use them because you want to use them consistently. So, uh, and in going into 0.7, there are some issues with the temp where you have a temp allocator. So it's like maybe T something, but if you have something longer, it's like if it's init, it's like usually it's like a T init. But if you have something longer, like with new with blah, in that case it might be like T new with blah. But if you have to copy, so to copy in that case it might be like to T copy and so on. So some naming issues remain, but this was to be the big one, and that's like just going into init, and that's it. That's it. You're going to take an allocator, but you can always take mem. So it's not that you're passing down the allocators like you have to do in other languages, like some languages, and but but you can um, for the things where you need to pass in the allocator, you are doing that explicitly. So this is also changing some things like the naming in the hash map. So if we look at the hash map in 0.6, no, that's wrong. Let's go to the hash map. And there's a problem with like taking the keys. So we have like value t list, right? So it's like a list of a temporary list of values. So it's gonna do copy. There's this copy of values, and there's like the value new list, which was the old name because now it's like copy values. But copy values is like also so. So it used to be like a value new list and value new temp list and so on, and that's just going into and then there were copy values, but going into uh, lib7 instead, we then have for that hash map. Let's go to values. So we're then with just values and t values, right? So with the temp allocator and the given allocator. And yeah, and the change that you have to what should follow is that if you have the allocator, that one goes first. So it's always like the init mem, then the arguments. Um, yes, and I think that's pretty much it. Okay, so I don't know. Are there any other questions here? Otherwise, I am going to. I think I'm done. Talking about 0.7. So a lot of like to repeat things going away. The old syntax, the new init thing, the expression block, the construct, um, and all the lists and so on will change so that they use a temp allocator by default. The init functions and so on, they will take an allocator explicitly if they need one. They won't have anything that takes oh sorry an allocator as a default argument anymore. And we just made the allocator very, very short to type. So that's it. And yeah, thank you for watching, everyone. And have a nice evening.